Hello everyone, today we will talk about transaction with Spring and JPA. JPA stands for Java Persistence API. Before we proceed with Spring transaction, let's discuss a little bit about transaction. Transaction is basically an agreement between buyer and seller in exchange of goods, services, or some assets to get some money or something equivalent to money. Okay, here we take some overview. We will discuss right way to configure Spring transaction, how to use transactional annotation with and common pitfalls. Basically, there are two distinct ways to configure transaction annotations and AOP, each with its advantages. We are going to discuss more common annotation config here. Okay, it introduces the enable transaction management annotation that we can use in configuration annotation class to enable transaction support. And this concept was introduced in Spring 3.1. Okay, so as we can see, there are two beans. Okay, first bean has a class local container entity manager factory bean, and there's a method, and that method is indirectly used here in JPA transaction manager. So as we already know, according to Spring Boot core lecture, every object inside Spring container is a bean. Okay. Okay. However, if we are using Spring Boot project and have some dependencies like Spring Data, Spring TX dependencies on the class path, then transaction management will be enabled by default. It means we don't need to enable it manually. Okay. So here we have a transactional annotation. With transaction configured, we can now annotate a bean with transactional either at class level or at method level. Okay, so let's have a look at this annotation service. I comment out this part of the code and I will give you the reason why I'm commenting it now. Okay. So I annotated this class with transactional. Okay, so Spring Framework will automatically inject at the beginning of transaction and at the end of transaction. That injection will be done by Spring Framework. So let's go inside the transactional annotation. In transactional annotation, we have got some parameters or some fields. Okay, this is a value. This is an alias for transaction manager. Okay, here we have got a propagation. There are 7 types of propagation. Okay, isolation. There are 5 types of isolation. We will discuss both of these concepts. And here we look at timeout. So basically, when we start any transaction and that transaction is supposed to be finished off within a certain time, and if it doesn't finished off, if that transaction doesn't finished off, it means transaction will be rolled back. Okay, we can also configure transaction in case some during the transaction, if any exception has occurred, then transaction will be rolled back. If some exception has if during the transaction, if some exception has occurred and that exception can be ignored from transaction, okay, in that case the transaction will not be rolled back. That is quite a special case. Okay, so suppose there is a component A and there is a component B. Component A made two transactions. Okay, first transaction is of $20, second transaction is of $40. To component B, first transaction has happened, but suddenly, because of some mistake in the second transaction, some exception has occurred. But that exception has nothing to do with the first transaction. In that case, first transaction will not be rolled back. Okay, so this is a basic explanation of rollback and no rollback for. Okay, so here we can have a look at propagations. We have got some kinds of propagation. It is specified as enum. Okay, for example, we discuss support. So required, suppose we have a annotation transactional required, it means transaction is required in this method or in this class. Okay, because transaction annotation can be applied either on method or on class. So what stands for support? Support stands for that transaction is supported. In case transaction is not already available, then there will be no transaction applied here. Okay, mandatory stands for yes, there is a need of transaction. Required new means if there is a transaction going on, then there must be a new transaction started. And if there is no transaction, even though there must be a new transaction started. Not supported means transaction is at all not supported. Okay, and there is no need of transaction here, and there is a nested transaction, like there is a transaction going on, then there is a nested. Okay, so here we have default, read, and committed. I will go through a little bit about this one two bit later. Okay, now I remove this thing and uncomment this piece of code, and I will explain you why I'm doing it. Okay, annotation support further configuration as well. Propagation type of transaction, isolation level of transaction. Timeout, we discuss about timeout. See, read only is configured as false. Okay, and it is a bit confusing, and we will get to know why it is confusing in very short time. So rollback rule. Okay, note that by default rollback happen for runtime. Unchecked exceptions only. The checked exception does not trigger a rollback of transaction. We can of course configure the behavior with rollback and no rollback for annotation parameters. Okay, we also discussed these things. And let's proceed with potential pitfalls. Okay, Spring create proxies for all classes annotated with transaction. It means Spring framework inject some proxies for before transaction and after transaction. So it injects some kind of transactional logic. So a proxy allow framework to inject transactional logic before and after the running method, mainly for starting and committing the transaction. So we might have heard a lot about the Spring framework, that many things happen behind the scene. So Spring framework inject proxies, many things, many times inject proxies behind the scene. Okay, so that's why it is also known as that Spring framework used lot of reflection. Okay, so this means that only external method call that come through the proxy will be intercepted. Any self invocation call will not start any transaction. Okay, this means that only external method call coming through the proxy will be intercepted. Self invocation call will not start any transaction even if method has transactional annotation. Okay. Any another caveat of using proxies is that only public method should be annotated with transactional. Method of any other visibilities will simply ignore that annotation silently as they are not proxied. Okay, so that we will discuss in the code. So here, this method will be considered for transaction. Okay, as it is written. And this method will not be considered for transaction from Spring Framework because this method is not annotated with public visibility. Okay, public access modifier. Okay, so here we are changing the isolation level. Okay, course DAO dot create runtime exception course. We can also change the transaction isolation level. Note that this has actually been introduced in Spring 4.1. If we run the above example before Spring 4.1, it will result in this. Okay, so it is invalid isolation level exception. Okay, so if we are using older version of Spring, older than 4.1, then we will certainly have some issues like this. Okay, and what is the meaning of isolation dot serializable? So here it is a very strict isolation. Suppose we are dealing with concurrent transactions. In that case, and we want to set some strict isolation, then we could consider using isolation dot equal isolation dot serializable. Okay. Today we are discussing only theoretical part, but in future we will do some practical examples, and those examples could certainly help us to understand different aspects of transactions, isolation, and propagation also in conjunction with propagation and isolation. Okay, read only transactions. The read only flag usually generate confusion, especially when working with JPA from Java doc. This just serve as hint for actual transaction subsystem. It will not necessarily cause failure of write access attempt. Transaction manager which cannot interpret the read only hint will not throw an exception with ask read only transaction. We can't be sure that insert or update won't occur when read only flag is set. This behavior This behavior is vendor dependent, whereas JPA is vendor agnostic. Okay, so it is basically a confusing stuff like read only. Read only is false by default. It is important to understand that read only flag is only relevant inside transaction. If operation occur outside transactional context, the flag is simply ignored. This is a simple example of method annotated with transactional. From non-transactional context, a transaction will not be created and read-only flag will be ignored. Transaction logging. Okay, a helpful method to understand transactional related issues is fine-tuning logging in transactional packages. A relevant package in Spring is org.springframework.transaction, which should be configured with logging level of trace. Transactional annotation is a metadata that specifies semantics of transaction. We have two ways to roll back a transaction, a declarative and programmatic way. Declarative approach, we annotate transactional annotation, make use of rollback for class name or no rollback. Okay, no rollback or no rollback for class name to avoid rollback on listed exception. Okay, the default rollback behavior is in declarative approach will roll back on runtime exception. Or let's see a simple example using declarative approach to roll back a transaction for runtime exception or errors. Here we have annotated a class with transactional course dot create. It will create the course and suddenly this exception will be thrown. Okay, we did not set any rollback. Then exception will be thrown. Next, we will use declarative approach to roll back a transaction for the listed checked exception. So here we set rollback for SQL exception. If this exception certainly this will certainly occur and transaction will be rolled back. If if let's see a simple use of attribute no rollback for transactional no rollback for SQL exception, then this exception will certainly occur and then transaction will not be rolled back. Yeah. Here we applied the same principle. Okay, so here we applied the principle of if exception occurred then no rollback. Okay, so transaction will certainly be, it will happen. Okay, and in programmatic approach we follow this way. Okay, so create course default rating programmatic, it will create the course and if some issue some exception happened then exception will be cached here and this method will be executed. Okay, this part of the code will be executed. Transaction aspect support dot current transaction status set rollback. Okay, conclusion, this declarative rollback strategy should be favored over programmatic rollback strategy. Okay, this approach should be favored over this approach. I also agree with this thing because catch there are multiple reasons behind it and uh, we will discuss those reasons too. Okay, so conclusion, in this article we covered the basic configuration of transactional semantics using Java. We also learn how to use transactional annotation and best practices of transactional strategy. And thank you very much for watching this video. And in case you like this video, then please subscribe my channel. And I wish you a very nice day.